Hello everyone, hope you are doing well. So we are going to discuss few questions based on stoichiometry and mole concept practice question, and one question I'll be discussing based on empirical formula. Now, whatever you want to pronounce, it's stoichiometry, stoichiometry, it's up to you. So the very first question: mass of carbon anode consumed, giving only carbon dioxide in the production of 270 kilograms of aluminium metal from bauxite by the Hall's process. So this part we haven't ever discussed. I haven't discussed in my videos so far. This Hall's process is something that you will study in your metallurgical operations in 12th grade. So let's say now this is like only we'll be writing the equation that we need to be aware of if we are doing this question, that what happens in the Hall's process. So it's more or less like reduction reaction which is happening. So if we have aluminium oxide, so first thing we should also know what bauxite is. So bauxite is an ore of aluminium. So Al2O3 dot 2H2O. So it's a hydrated oxide of aluminium. Now, no need to consider water molecules over here. We'll be taking only aluminium oxide. This is also called as alumina. So aluminium oxide, Al2O3. So in this Hall's process, what is happening? Carbon is acting as a reducing agent. So it's going to reduce this aluminium oxide, and we are going to obtain aluminium. That's what the name Hall's process. This is used for extracting aluminium commercially, and carbon dioxide is released. So we can balance this. So now this reaction is something that we'll be discussing in the future classes in metals and non-metals. This is metal oxides, and carbon over here is acting as a carbon anode, but we even call it as coke in the metallurgical operations, and it is reducing this metal oxide into the respective metal, and carbon dioxide is getting released. Now this is our equation, that is Hall's process. So mass of carbon anode we need to calculate in the production of how many kilograms of aluminium metal. That we are getting is 270 kilogram, or we can even take it in gram, 0.27 gram. So aluminium mass, now in these equations what we need to consider is the actual gram atomic mass. Now aluminium gram atomic mass is 27, so 4 into 27, that will be 108 gram. Now, why I'm taking this 4? 4 is nothing but the number of moles, or you can say 4, moles or molecules, anything you want to say. So, according to the equation, that's why I said stoichiometric calculations. So, actual, like if we say, 1 mole of carbon is basically giving us how much aluminium. That's why balancing this equation is very much important, because if we don't have the standard balanced equation, we won't be able to solve like how much carbon anode we can is consumed. So what we are doing over here, we know that aluminium is 270 kilograms of aluminium metal, like that is you can say already produced, right? We need to find that what mass of carbon anode was you can say used or utilized in the production of 270 kilograms of aluminium. So that we need to do, but we can't calculate the weight according to the question if we don't know the standard ones. So first thing, aluminium oxide is getting reduced, that equation we wrote. Then we need to balance this. Balancing is very much important, and the only important thing that we need to focus over here is this carbon and this aluminium. We don't have to deal with aluminium oxide or carbon dioxide, because they are not asking that part in the question. So four options are given over here, so that we'll come to the answer. So we know that if we balance this equation, how much aluminium? 108 gram. is getting produced from, and how much carbon is utilized in this. So this will be 3 into 12. 12 is a gram atomic mass of carbon. So 12 into 3, 36 gram. So these are standard. Now we are going to utilize it. So let's say 100 gram of aluminium is produced from how much carbon? That is 36 grams of carbon. This is an equation. This is, we have written according to the standard equation. That's how you need to write it. This is standard. Now we have how much aluminium given in the question? 0.27 gram. 0.27 gram of aluminium is produced from how much carbon? 36. Now crisscross. This is a simple unitary method that we use in mathematical calculations, right? Like if we have, let's say, if we have 15 eggs, which is of 15 rupees, then 30 eggs will be of how many rupees? That's a very simple example. But please understand, so this is going to be something we call it as crisscross. So 36 divided by 108 into 0.27. So once you solve this, so you will get 0.09 gram, or we can even say 90 kilogram, because in the options they have given in kilograms. So this is the answer. So this is a simple unitary method we solved, but we need to do a little preparatory before this question. So yes, in mole concept and stoichiometric calculation, these kind of questions can be asked. This is a little, you can say, a higher level from the ninth and 10th grade, but it's okay. You should know. Even they can ask you simple questions like already chemical reaction and equation. So they can take up equations from there, and they can make a question based on similar concept or similar way, similar, you can say, the way we have done. So they can actually give this kind of question also. So remember, bauxite is an ore of aluminium. So moving to next question. Now, what volume of oxygen gas measured at 0 degree Celsius and 1 atmosphere is needed to burn completely 1 liter of propane gas? They have given the formula of propane. It's a hydrocarbon. So measured under the same conditions. Now, first we need to understand few things. Now, propane C3H8. Now, whenever it's going to burn in the presence of oxygen, any hydrocarbon, okay, this is a hydrocarbon. First, we need to understand what's a hydrocarbon. So, it's a compound of carbon and hydrogen. So, in detail, we'll be discussing in carbon and compounds. So, C3H8 is propane gas. So, when it is under, you can say, burning in the presence of oxygen, it's going to produce carbon dioxide and water vapor. This is, you can say, always going to be there. Any hydrocarbon burning in the presence of oxygen will give you carbon dioxide and water. Now, it depends, like if the oxygen is limited, if they are going to write specifically that oxygen gas is limited in the question, then there is a possibility that we will get carbon monoxide in the product instead of carbon dioxide if the oxygen gas is limited. Otherwise, if it is not mentioned, then you can just write freely carbon dioxide on the product side. Now, this question is a very simple one. We don't have to even do any calculations in order to get the answer. So, first, we will be balancing this, and this is in the gaseous state. Oxygen is in the gaseous state, carbon dioxide in the gaseous state. So water, we can say in the, you can say, because it's a burning process, so we can actually take in the gaseous form, it's in the steam form, right? Even after cooling, it will be changing into liquid form, so we can consider it as a gas water over here. So now this I might have discussed somewhere in the characteristics or in the chemical reactions and equations chapter. So this is something called as Lusak's law. So according to this law, if we have any kind of equation where the reactants and the products are in the gaseous form, then the stoichiometric coefficients, the numbers that we are going to use to balance this, can be taken as simple whole number volume ratio. So I'll write it over here in a simple way. So stoichiometric coefficients can be taken as simple whole number volume ratio, provided, now this is a condition, the reactants and the products are in the gaseous state. Now, even if one of them is in some other state, solid, liquid, or aqueous state, any other state, then we can't apply this law. This is only for those kind of equations where the reactants and products are in the gaseous phase. So only then we can use it. Now, first we will try to balance it. So carbon 3 atoms, we can put 3, like the same hit and trial method which I have told in the chemical reaction and equations chapter. You can, you can watch those videos in order to learn. And then we need to balance oxygen. So this is going to be, yeah, yes, it's perfectly balanced. So now we can actually consider these coefficients as a mole. We know that number of moles is directly proportional to volume. Again, you can watch the mole concept videos which I uploaded. So number of moles is directly proportional to volume, right? So this was, like, you can say Avogadro did that. So this is old law. This is not correct for every kind of equation, but number of moles we can apply for any kind of equation. So but over here we can take the coefficients as a simple whole number volume ratio. So this propane will be one volume because there is only one coefficient over here which I didn't write, no need to write. And 5 volume of oxygen reacts together to give you 3 volume of carbon dioxide and 4 volume of water. Now according to this, they are asking what volume of oxygen gas. So we figured it out just by balancing. So it's 5 liters, 5 volume, or you can say simple whole number volume ratio. So since they are talking about 1 liter, and one more thing, since they are mentioning 1 liter, so this needs to be 1. You cannot increase the coefficient, you cannot take this as 2. If there is no need also, without you can say putting you can say 2 coefficient over here, we are able to balance this. But sometimes uh, fractional, you can say the coefficient, fractional coefficient also comes, like depending upon the equation. In that case we have to see what volume options are given in the question. So for 1 liter means we can't increase this number. So if they would have given 2, then it would have been a little different story. But for 1 liter, so it's going to be 5 volume. So we go to the next question. Volume occupied by one molecule of water. Now, I can do this question based on the formulas and this unitary method. So we know that number of moles is equal to given number divided by Avogadro constant. This I have discussed in the mole concept. You can say that video. In couple of videos you can go to my channel and watch there. So this is a given number, right? And they're asking about the volume, and this in turn is equal to V by 22.4. So because number of moles are given by two relationship, given number divided by Avogadro constant, number of moles is also equal to V by 22.4 liter. So we can compare these two relationships together. So now if we say one molecule, right? So this number, this capital N is 1, 1 divided by Avogadro constant. So, and they're asking about the volume. So V by 22.4. Now, we cannot use this particular formula in this question. Why I took this? Because immediately it comes, if you have watched those videos, if you are aware about these you can say relationships, you will immediately say, okay, volume should be 22.4 liter divided by Avogadro constant, and that's it, done. So we should get that answer, right? But it's not that simple, because in the question they have given us density. So we need to calculate volume occupied by one molecule of water. That's okay, like we can calculate it. So now, so if we try to do this, then we will get a different answer, because we are not considering what they have given in the question, that is our density, right? So if we take this into consideration, so we know density is equal to mass per unit volume. Mass of water, we know, that is 1 into 2 plus 16. This is 18 gram. Gram molecule mass of water is 18. And we can actually take this. So V is equal to mass by density. Density is given 18 divided by 1 gram per centimeter cube. It's already given, if you can see this. So this will be 18 centimeter cube or ml. So this is the volume that we have, basically calculated for water whose density is 1 gram per centimeter cube. But now they're asking one molecule, right? And this, like, how we figured it out, this one. So we need to consider that number of moles is equal to given mass, right, divided by molar mass, that is equal to given number divided by Avogadro constant. So these two are directly linked, given mass and the given number. So I can say weight of 6.022 into 10 to the power 23 molecules of water is equal to 18 gram. How? Because this is also 1 mole, and 18 gram of water is also 1 mole. So they both are equal. So we can actually then do this. Now, after this, they are going to ask us about the volume occupied by one molecule. So since we have calculated the volume, right? So now we can calculate the answer. So we can even say that, like, since 18 gram and this weight, all these are directly linked, the mass, number, and the volume. So I can say that, these many molecules of water, which is 1 mole, is also equal to 18 ml or 18 centimeter cube, right? So one molecule, because they asked one over here, right? So one molecule of water will be equal to how much? 18 divided by 6.022 into 10 to the power 23, and when you divide, so this will give you somewhere approximately 2.9 into 10 to the power minus 23 centimeter cube. And you can see in the option also centimeter cube or ml. We know that 1 ml is equal to 1 centimeter cube, so it's same. So either centimeter cube or ml that you take. So over here, now if you if you see the approximate answer that we have over here is 3. This is minus 23. Okay. So this is first option. Approximately 2.9, we can take it as 3. 3 into 10 to the power minus 23 centimeter cube. That's our answer, right? So we'll move to the next question. Now this is based on empirical formula. So organic compound containing carbon, hydrogen, and oxygen. So again, if you have seen my empirical formula video, or if you already know how to calculate it, then you can understand better. So its elemental analysis gave carbon 38.71%, hydrogen this much. So obviously the third one you have to calculate. So we will add these two. So you subtract from 100. So if you add it up, 38.71 and 9.67, so whatever value you will get subtracted from 100, so you will get oxygen. So you can do meantime, like you can calculate the oxygen one also. So these are the options given. So we need to find the empirical formula. So how we are going to do, if you have seen that empirical formula video, so we are going to make a chart over here: element carbon, hydrogen and oxygen. Then the percentage they have given: carbon is 38.71, hydrogen is 9.61. So oxygen we need to calculate. So 38.71 plus 9.67, this will give you 48. So I'll just write it over here: 38.71, 9.67. So 48.38. Now you need to subtract. So this will give you 51.62. So now we have the percentage. Then we will write the atomic mass. For carbon it is 12, hydrogen is 1, oxygen is 16. Now we have to calculate the mole ratio. So the number of moles that we're going to calculate. So this percentage can be taken as grams, like 38, because percentage gives you this much gram in total, 100, right? 100 gram. So 38.71 divided by 12, 9.67 divided by 1, 51.62 divided by 16. So this is 12 threes 36. So this was approximately 3 and point 2. This is 9.67 only, and this will be 16. So 51. So with 3 it can go 48 here. So this is again going to be approximately 3.2, right? You can take two decimals, but one decimal is also okay. If you want to take two decimals, you can, because 9.67 is there. So we can take the second decimal also. So this will also come to be 2 by dividing it, and the next division will be also 2. So two decimals we'll take, because 9.67 is there, so we still have two decimals. So let's follow that. Now the next least value simple ratio that we need to find. So again you need to find the least value. Least value is this. Either you can take for carbon or oxygen. So both are 3.22. So 3.22 divided by 3.22, this will give you 1. 9.67 divided by 3.22. So this is approximately 3. Right? Approximate we will take. Now, if it is coming 5, 3.5, then obviously we have to multiply the whole, but in this case it's not. Okay, so even if we try to do, so this is coming to be 3.00. So it's not, you can say, it's not going to be 3.5. So we are okay with that. So 3.22 divided by 3.22, this will be 1 again. So carbon simple ratio is this: carbon is 1, hydrogen is 3, and then we have oxygen 1. So this is our empirical formula. So they didn't ask you to calculate molecular formula. We are not calculating it. We don't need it. So the option over here is CH3O, third option. Now we go to the last question. The number of atoms in zero point 0.1 mole of triatomic gas. Now Avogadro constant they have given. Otherwise, you can take 6.022 into 10 to the power 23. But since they have given, so we will use this only. Or we can actually change this. Just this is 23. No need to write because it will be technically wrong. So 23. So this is a very simple one. Number of moles is equal to given number divided by Avogadro constant. We know that. So we can do this way. 1 mole of triatomic gas. We don't know which gas they are talking about. So but atomicity is something very much important for us. So Avogadro constant into 3. So if you go back to again the same, in my previous lectures I have discussed that 1 mole of any atomicity matters a lot if we are calculating atoms. So triatomic means atomicity is 3. There are 3 atoms in one molecule. So this will be, you can say, for 1 mole. Now they are asking for 0.1 mole. So into 3 into 0.1. So this will be 18 something. But we have 0.1 also. So decimal will be, you can say, 3. So this will 1.8066 into 10 raised to the power 23. So these many atoms, this is the answer, this one. Now you can do with this formula also, that's not a problem. So number of moles given is 0.1. The given number that we need to calculate, capital N, Avogadro constant is 6.022 into 10 raised to the power 23. Again you have to multiply with the atomicity, that's mandatory, and again you will get the same answer with the formula also. Same answer. Right? So I hope these questions were helpful for you. I'll be uploading these kind of videos more. And there are many concepts in chemistry. Again, as I repeat, we can't teach in one day, but I'll try my best. So, not teaching in one day, but to upload content almost every day. But I cannot promise that, but I will try. So, if you like this video, then please subscribe my channel, and you can share with your friends. And if it was helpful and you were able to understand, so please share, and you can like if you understood. So, in most of my videos, I forget most of the times to say this out loud, but like if you really want to support, and if I was helpful in any way, then please. Thank you so much.